Hi, and welcome to the summary of live coding session 7 and 8. Um, we have been going through a lot of steps. We've been doing some testing, and we've added security to the API. And for the last session, I forgot to make a summary, or I ran out of time to make a summary, rather. So I'm going to wrap them into one session. So let's first start with testing. In the live coding session, we went through the various ways that you can test Clojure code and clojurescript code. So let's take a look at what we did. In our normal project, we created, and this changed from the live coding session. In the previous live coding session, we discussed the transition of the API to its own component. In the testing live coding session, it was still part of the web server. So for now, it is in its own REST API code namespace. So it's called a REST API handler test. And basically how testing works in Clojure and clojurescript is that within the test folder, you create your same namespace. And let me start the thing. And from that, you basically hold on the same naming as you have your normal classes, and Clojure will automatically work that way. Cider itself has a lot of helpful tools for this. Also check out my Productive Emacs Cider edition on testing. I will link it somewhere above here, I guess. There. So there's a lot of tooling, and there's different strategies that you can take in Clojure to actually test your code. And what we did during the live session was to just run through those various ways, from having plain tests to having a full mocked session. So the REPL is starting up right now. We will see the clojurescript code being compiled right here. It will take a little while. On the playlist, you would have seen that we are stuck at Trivia Game Summary 6, while the live coding we just had 8. So we'll fix that now. So there we go. Let's quickly load up the interface, because else the REPL will hang, which is not very nice. All right, so here we go. Let's first cover the plain testing. It's probably on the bottom here. The tests, the record test fixture. Yeah. So we have this this one test, and if we remember the REST API handler, there is this function that we created. It looks a little bit different. Yeah, here we go. There's this function that we created to read a string from the environment, split it up into based on the comma, and then create regular expression patterns from that. And that would be used in order to validate that the calling client is actually allowed to use it. So, and that's called the course list. So it's very innocuous code. All it does is check if the input is empty, and then return an empty array, and else it creates an empty vector with those regular expression patterns. So how would we test that? Well, first thing, Clojure test wants you to use the dev test directive, the macro. It will create a set of tests, set of assertion that is one test. In this case, in the most simple form, you can just do a dev test and then give it a name, and then add assertions. And the is function is actually an assertion. So what should happen is that the system under test, which is the namespace given to it right here, the name, and the REST API handler is called the SUT, the system under test. And if we look at what we do, we just call it with an empty string, and that returns an empty vector. So comparing that to an empty vector will yield true, and the is function then yields true as well. Suppose that we added something here, and then this function will return false. And in the bottom you see here that it failed, it expected A as a result of this function call, and it got A and an empty vector. Exactly what you would expect. So let's remove that, it works now. What happens if you do a nil? That's also true. And then we had some interesting an exercise in getting the regular expression pattern out of a string to compare, because a regular expression pattern is not compared on the pattern itself, it's compared to the object. So just comparing the result array that you would get from doing, let's see, we cannot run that here. So what we do now, we split the string, and then we create a new vector which takes the result of the function call and then calls the dot pattern on the object that is being returned, and that allows us to check the result of that. So if we run this, string split, no input, yes, input's one level higher, thank you. Are in somewhere around here, I guess. There we go. So that is true. So that's beautiful. And this one test, if you execute it, it just defines a test. So how do you run it? There is this key binding within CIDR, CT, and then you do T for test. And then it just runs the one test. It has 3 assertions, and it tells you that it is fine. So that's the plain vanilla test in this case. Then there is something else. You can use property-based testing, and property-based testing will just give your function a lot of permutations based on the input description that you give it. So in our case, we have a string which is a list of comma separated characters. And as an example, it's not really a totally valid use case, but it works. We created our own generator. So we created something that generates comma separated strings for us. And that was done by using the fmap functionality from the clojure test check library. And all it does, it generates, it joins strings with a comma, and those strings are generated in a vector using the string accepted definition. And that in itself is a generator which generates strings based on the characters that are accepted in our example. And for now we have characters that are acceptable if they are between character ID 97 and 122, and we go to ASCII-table.com, and then we can see what that is. 97, 97, 96, 97, that's A through Z, lowercase. Then we have A through Z uppercase, and 48, 59, 48 is somewhere around here, 0 through 59 semicolon. So what it will do, every time the generator is being called, it will give us one of the characters from this list, and the string will make that a string, and then those individual parts are built into one string, which will be the input to our function. So if we say we can give me a sample of this CSV string, can we do it like this? Yeah. We need a factor for this probably. Gen factor. Hello. Hey, my par edit is not activated. That's interesting. Mode. That was interesting. Oh, it's probably not evaluated. Save file, yes, please. So if we run it, we see that the generators first start with a very small set, being 0 items, then 1 or 0, and then 2 items, and then somewhere between 2 and 0, and then it builds up in size, and it just generates random strings. So our function here, our prop for all, is then given this non-empty CSV string as input, and it runs over it and basically does the same thing that we did right here in our plain text, but now it will give it 100 permutations of random input, and it would allow us, if we have more complex logic, to find edge cases, and then when the test fails, the test check will limit the amount of data being sent to just the ones that make the test fail. And then it will tell you, hey, your test failed based on the input of these characters. And you can actually find nice edge cases from that. So if we run this, it will say it ran, but in the REPL itself, it will say, hey, it was all okay, but I did 100 tests. I created 100 strings of random data, and your function handled it quite nicely. So that's the second part. So we have a plain vanilla test where you define everything that goes in. So only the cases that you enter are checked. And now we have some generators which will generate random data based on your input. And now with those you can basically test pretty much any combination of data. But we also have an API that takes a HTTP request, does some logic, and returns. And you probably want to check those as well. So how do we do that? Well, we need a fixture. We need to create our own implementation of a database that can be used by an API, and then we need to mock the request from the API all the way to the database and then back. And that sounds very complicated, but in the end it turned out to be quite easy. So what do we do in order to test our API? First, we need a database that will allow us to define the data that we want to test with. So for now, we created a test fixture which implements the DB protocol DB actions, which grabs a random question, which will always be 1, 2, 3, 4, how cool is clojure_script, and it will return true on the call to correct answer. It's very specific, and for now it works, but you might want to elaborate on this. And then we generate, or we made a function that generates a new test fixture. And for now, what we did was to say, here's our test case, and we told our system first to just do a create a handler with no database fixture of anything, because we don't expect a call to actually go through to our API. And then we told it to run this mock request, and this will create a ring HTTP request, which will be seen by the API as an actual HTTP request. In this case, we call not found, and what we should get is actually a 404, and we can check multiple bodies of the request, the headers. We can say, well, what would the body be that we expect, and we can actually this will be compared to the result there. So we can do some very fancy things here. And on the other hand, we had a fixture that we need, and we want to actually compare some of the requests there. So with the fixture, we instantiated a handler from the system under test, and from that we did a mock request to the API's question endpoint. It actually should be questions, I guess, but we called it question, and from that we take the resulting status and body elements. So that those would be the one being questioned here, the status key and the body key, and we can check those and check what resulting value will be. And at the moment we expect a 401. Because in the last session we actually added user authentication, and that made that the API endpoint itself is no longer freely accessible. So a call to it without any access will result in a 401. And if you run this, it will tell us that everything is fine. And now we tested our code in 3 ways: plain, we did some property generation, and we used fixtures and mock requests. So with that, you can basically go and test your entire application. I wonder if I can just start it at the moment. Will that work? Yes, it works. Beautiful. So with testing behind us, we added user authentication, and most of it is actually done in the REST API handler itself, and I believe there's a little bit in the web server. What we used for user authentication, and our use case at the moment is we have this one isolated server on which we have our small application. And so what we want to achieve is to have a server-side session which holds the authentication and everything for that user. In the real world, if you have a large-scale application, you might want to move into a token-based validation. But for now, we use a server-side session. And to identify the user will receive a cookie to identify that session. So every time the user does a request, it will pass us the cookie. We will look up the cookie key into our local session store. The server will then find the session and then say, oh, based on that cookie, this is the user and this is his data or her data. So what we did, we created a cookie name called Trivia Session, and we started using a session backend from the body out libraries backends, and one of them is a session, so we use that. And then we created some handler code that wraps the handler, and we create some middleware that wraps the handler through the wrap authorization and wrap authentication, which are part of the body out framework. And then we used the ring middleware wrap session to ensure that we can actually have a session in our HTTP request, and that results in that cookie being set on the client side. So if we go to our endpoints, we go to API docs. It has the Swagger endpoint, and for now, if we take a look at our endpoint that would be generated, I need to put in the right information. So we created a user called Arjen with the username test, and it should result in a 200. That's fine. But what can we see it here? Access, no. Network. Let's do it again. Where are you? Here you are. There's the login. and we should see a, oh, in this case the cookie was already set, so we're not getting it back, but you see that there's a cookie ring session with a ID, a UID, being created, and that is due to this wrap session middleware. And then we created another helper function which just wraps all the middleware around the handler, and in this case we only have this one middleware that we want to use, but we could add more. It's called wrap app session, and this middleware itself is being used to actually wrap the API. So on the web server side we have everything taken care of. So if we go to the handler, it becomes very interesting. We have some specific functions. First we have this function to just say 401, you're not authorized to access this data. The unauthorized is actually an HTTP response from the ring library. The other one is a wrap rule, which takes the handler and then wraps an access rule around that using the body out library. And the rule middleware is quite simple, but it's very elegant. Let's take a look. So the wrap access rules will take a set of rules. In this case, we just define one that says anything on this endpoint will have to pass through the rule that I passed to you. So imagine that we have /API/question, and if we can add a parameter, question mark ID equals 6, then anything on that endpoint, no matter what you put there, will go through this rule handler. If there's an error, it will result in the unauthorized being called using this access error. And we actually use this function from another function, which is actually a multi-method from the Composure API, which is called restructure param. And that sounds very fancy, but what it does, if we go through here, we defined our own key to be used in a request. We already used the return, the path params, body, and summary. And now we created one that says out rules and the other is current user, but we're currently looking at the out rules. So we create the key here by implementing this def method here. So whatever key you define here, you can use in the API as a key. And that takes a rule and an accumulator. We update the accumulator, we tell it as part of the middlewares, you add this rule. And this rule is actually the call to wrap rule with the rule that is being defined. So the rule that we pass along to out rules will actually be taken, and then it will be added to the middleware that is being used by the API. And what it says, take that rule and use a wrap rule, which says anything under this endpoint, and in this case in the API endpoint, will be applied to this rule, or the rule will be applied to anything under that endpoint. And this is a use case that you would want 90% of the time, maybe 99% of the time. In case you need some specific patterns instead of dot star, then you would need to enhance this wrap rule and define your own out rules restructure param. And we created the other one, current user, which will actually take the user object from the session and inject it to a variable that you can use within your endpoint. That is done by updating the accumulator, the let keys item, and what we do there, we bind the identity from within the Composure API request, and we will see where identity is being set. And we bind that to the thing that is defined in binding. And how does that work? We have it right here. So we have this current user restructure param, and we tell it this variable cur user. It is defined at this point, and this cur user will then hold the thing that we put into identity of the session. So, putting this all together, we move to the post of login. So the thing that we did right here. We did a post to log in. My mouse is very funny. I think the battery is dying. Then we did a post to API login. It returned 200, so everything went fine. And what does that mean? We have the endpoint right here, /login. It accepts a post, and it takes a username and password as a parameter, so that we will see in the request payload. And mind you, in our environment, it is done through HTTP, so there's no encryption. You should not use that in production. You should use SSL in production, just to make that clear. So we defined this new function get user from DB, and in our DB protocol, it is a new protocol called user actions, and in our PostgreSQL DB, we created a new user action UR here that says get user by name from the pool with the username. And if we go to queries, it will have a new get user by name, selects the username and a hash. And the username and the hash are from a table called users. Test the username and the hash. And we already created a one user, Arjen, with the password test. So feel free to use that. And at this point, the username given into the call will actually be retrieved. It will retrieve the username and the hash, and that will be available in the user object. So then we use the body hashers to actually check the password being given to the hash from database. And if that is okay, we return HTTP 200 with a empty JSON object. But what we do is we do an associate into the object being returned by OK. And that means that the key session identity, so the session from the HTTP request, will have a key called identity, and that will contain a map with the key username and the actual username of the user. In case the request fails, it will return a 403. You are not allowed to use this server, it's forbidden. And it will actually set the identity to nil. So it basically cleans up the server-side session. So at that point you don't have a username, you will not be authenticated. And if we go back to this restructure param, you will see that this identity, this key, is retrieved from the API request, and thus what is being passed here is actually the session that we already have. So given that, this will make sure that the user is fully authenticated and is known in the server-side session. And if we then call the get API question, let's give it a try, it returns a result. And in the server side, it says user requesting a question is Arjen, and that is right here. We see that the question endpoint now can only be called when it is authenticated, when the session is authenticated, and it can read the current user object map from the variable cur_user. Is there anything else to see here? No, that's the same logic right here. So our user is now authenticated, and that means that when we go into our application, we do the console, we do a login, it will say forbidden. We should add some error handling here, of course, but and if we do a call to our test, it will actually work, and all the calls will be authenticated, and everybody will have a good time. So in the end, we're caught up now. We covered our testing from simple pure object testing to closure test check, property-based testing, to how to mock something. There's a lot of background there. Go into the live session if you're very interested in it. I suggest you do it because you learn a lot of things about the testing, especially things we ran into during the live coding session were very interesting. On the authentication side, we used Buddy and the libraries that are part of the Buddy framework. We added security to our API. We can limit the access to endpoints based on being authenticated or not, or we can create our own rules and define if somebody is authenticated or allowed to use it, perhaps being an administrator or something. We can use the user object from the session in our code, and with that we have come full circle. Next week we will actually add user sign up and then selecting those users as friends to play a game against. So that will be very interesting. I wonder if we can fit that into one session, but do check it out. If you like this series, please press thumbs up, comment below, share, and subscribe to the channel. It's greatly appreciated, and I hope you liked it. Thank you.